Okay, so we're going to go over some concepts before we start word problems. Go to page 35. Now we've learned how to solve for sides / angles using sine, cosine law. We can start solving for word problems. Okay, leave this blank for now, that is fine. Definitions and terms that you need to know. I talked about angle of elevation and depression, correct? So I will not do them at the same time right now. I'm going to do them separately. Angle of elevation, almost always there's going to be the ground and maybe a plane up there, or there's going to be a building or something. But your tendency is going to be to look up. Okay? So this is your horizontal. And so that's the angle of elevation right there. That's going to be a number at some point, right? Angle of elevation is going to be a number. But if you hear the question mention it, you're guaranteed your triangle will look like this. I mean, it could be coming from the right side or left side, but you're going to go up with your slant, right? Angle of depression, it's usually when you're up here somewhere and you're looking down into the valley, down like you're flying on a plane, or you're flying your drone or something, but you're looking down. In that case, quite often the horizontal is imaginary. Like there's no ground up in the sky, right? There's no horizontal line, so you have to kind of make this horizontal line yourselves. And then you do have a slant, of course. And then this is the angle of depression right here. But it is measured from respect to the horizontal. And this is why I'm saying, imagine you're up on at the top of a cliff, okay? Don't draw this part right now. I'm going to erase this. But students draw their cliff, and they're like, and there's an angle of depression of 30 degrees. And they want to put the 30 in here. That is wrong. It has to be with respect to a horizontal of some kind. So not here. Maybe we can leave the cliff here, right? Actually, so when you flip through your notes, you're not tempted to put it there. You know it goes there. So there we go. That's angle of elevation depression summarized. The other one, supplementary angle, is angles whose sum is 180 degrees. Mr. Jackson, we just did that. We know it. I know. This is where supplementary angles come in handy. I will give you a short little illustration here. If you have a ruler, actually for this unit, you might want to have a ruler for the diagrams. Supplementary angles go as follows. So imagine this is the ground here. It could also be from the top, flying a plane or whatever. But let's imagine for a moment there's a tree here. And it says that Abby starts here, looks to the top of the tree, and there's an angle of elevation of 30 degrees. Okay? Now, Abby moves 10 meters towards the tree. This would be Abby number 2, right? Abby's second location. And it says that now the angle of elevation is, let's say, what's going to happen to the angle of elevation as you get closer to something? Is it going to go up or down? Right? As you get closer, you're going to look further up, right? So this will be 40. I'm just making this up on the fly, right? How much closer did we get here again? I said 10 meters, right? I don't care, just give me a number, I'll write it down, right? That's what you're thinking. Do you see the supplementary angle there that could come in handy? Because right now, the only side you know is this one, which is part of this triangle right here. If this is 40, then this is 140, correct? You see that supplementary? Okay. So it'll come in handy. So I always tell my students, if you see a hat, right, if you can somehow find a straight line that you can make a hat with, right, and then you're like, oh, these two are 180, bingo, you're in, right? Like that's going to be very helpful figuring that out. And then there's complementary angles whose sum is 90 degrees, just a refresher. So what would you be thinking of there? Quite often there is a scenario like this where you're looking down. This is point A, this is point B. How many triangles do you see there? 2, right? So let's say you were given the angle of depression to be 30, but you want to work, there's 90 there, there's a 90 there. You want to work with this triangle here for some reason. If that's 30, then this is 150 at 60. You know why I'm saying 150? Because students think it's always supplementary. Everywhere we go, it's just going to be minus 180. Not always, right? It's going to be, in this case, it's 60, correct. So that's going to help you. That knowledge is going to help you, okay? Guy wires. You know what a guy wire is? I'm actually curious to see how many of you know what a guy wire is, because it's still in word problems and textbooks and whatnot. Nobody's heard of a guy wire? What were you doing in grade 10? Because there should have been a word problem with it. Anyways, a guy wire, anytime, I'm thinking of a hydro pole, right? You've got a hydro pole. Anytime you have a wire supporting it, that is a guy wire. So if it's a post out in the fence, like if you go to a cattle farm and the posts have like a wire supporting that corner post, that's a guy wire. And you can tell that this is going to make a triangle, right? And so a guy wire is just a wire. You know what a grandfather clock is? Oops, clock. I heard a yes. Who said yes? It's a clock. It's one of those old school. My grandparents used to have one of those. This is your clock, right? But there's a pendulum that swings back and forth, right? It goes back and forth, and it's super loud. It goes off by the hour. So if it's 1 o'clock, it'll go bing, right? If it's 2 o'clock, it'll go ding ding. So if I went for sleepovers at my grandparents, and it was midnight and you're trying to sleep, you're gonna hear this 12 times, and then at 1 in the morning, and then at 2 in the morning. And they're like, how was your night? It was terrible. That clock needs to stop. So they stopped it when we came over for sleepovers. So I wasn't used to it. They were used to it. Anyways, so grandfather clock, and one more that I think I will leave for now. Or should I? You know what? I'm just going to do it. I think you can handle it. Just draw a triangle like this. What? So from this corner, you make another line like that. If this is 30 and this is 50, what's that little sliver here? You can do it. What's this angle right here between these two slanted? 20, right? If this is 30, from the ground to the first one is 30, and from the ground to the second one is 50, then this is 20 degrees. Okay, so you just go 50 minus 30 is 20 degrees, and that's the angle formed between the two. So sometimes they'll tell you an antenna has two wires, two guy wires. Hey, there it is, supporting wires. They say that the first one is attached at an angle elevation of 30, the second one at 50. Okay, you should be able to figure this out that this is 20 from that information, okay? All right, where are we at? Pythagorean theorem. Don't forget about your good old friend Pythagoras, right? I'm going to give you the short version of this one, okay? I will not use ABC. I know that's what your teachers in the past have done. I will not use ABC. I will use when you have a 90, the one across from it is called, the side across from it is called hippopotamus. Have you seen those shirts? There's a hippo kind of going up the slant on the ramp. Anyways. And then these ones are called legs. I know you call them A and B. I know that most teachers call this one C, and then they went A, B. Okay? I will not. In general, okay, the hypotenuse squared is equal to leg squared plus leg squared. So from this we've got two formulas that I use all the time, but it's based on this formula here. Hypotenuse, if you want to find the hypotenuse, you take the square root of the answer that you get when you square both legs and add them up. Or, so this is if you want to know the slant. You add up the other two, you square them, and then add them up. Or if you want to know one of the legs, because you know the hypotenuse and a leg, you do it this way. Leg is equal to hypotenuse squared minus the other leg squared. Okay, so these two formulas. Mr. Reason, what if I want to stick to ABC because that's how I learned it, and I'm going to stick to it? You go for it. I'm fine, but I like to think of it this way. So if you want the slant, just take the legs, square them, and add them, take the square root. If you want to have the leg, if you want to know it, hypotenuse squared minus the other leg squared, and then square root it, and then you get it. I should say only works with right triangles, because some students try this and it's like, no, it's not a right triangle, don't try it. In fact, this is very rare that you're going to use this. I'm just reminding you in case you want to use it down the road. Still with me, right? I need to start like making like a dance routine or something to entertain you a bit more. We don't want to see that, right? That's what you're saying. Okay, let's go to 36. I will just, I won't stick to 36 too long here. I will just show you some of the things that you can encounter. I will take another day to go over this in detail. So go to 36 for now. And look at this ship on top of the water. You wish water was nice and flat like that, right? But do you see that line, the surface of the water and the ocean floor, we would consider them parallel. What do we call this line then? If you have one parallel connected to another parallel line, what do we call this line? Yes. So if this is 30, what would this be? 30. Why is that? Alternate interior angles. So see how it comes back? Okay. If this is 45, then this is 45. Right? Alternate interior angles are congruent. That's what we're using there. Do you see a supplementary angle there anywhere? You see a straight line here, and then could we make a hat here, upside down hat? Yes. So we could figure out the angle from here to there, just go 180, take away this, take away that, and then we got that angle there. I'm going to use a different color for that one. So if you wanted to find this angle, okay, you can say, you can go 180 minus 30 minus 45. This is 75, right? So it's 105. Voila, you all of a sudden have 105 degrees. It's from end to end, like from one slant to the other slant, okay? So that's the kind of reasoning I want you to start adopting. And what's the 1500? What do we call this? Height. Yeah, okay. Or depth, right? Ocean depth, like how deep is the water? It's the height of the triangle, sure. And also, you see, if this is a 90 here, you're guaranteed that this is a 90 as well. If this is 90, folks, and this is 30, what's 90 and 30? 120, right? 120, what would this angle be just here, this little bit here then? 60, right? If this is 45 and that's 90, that's 135. What would this little bitty piece be here? 45, right? What does that add up to if you go 60 and 45? 105. So there's not just one way of doing these things. You've got to be careful, and you should prevail. Okay. What do we call the 45? Just think of the 45 right now. If I were to just ask you this, what kind of angle is this? Angle of depression, because it goes from the horizontal, it goes down, right? So this is an angle of elevation here. This is angle of depression. Okay, so they're different. They're the same number, but we call them different things. Let's do an example here. We're going to focus today on just sketching. Because if you don't know how to sketch, if you don't know how to read and sketch it properly, everything else is going to suffer. Okay, everything else is going to suffer. So, I'll do the first one with you here. A radio antenna is supported by two wires on opposite sides. It's very important. There's two wires, right? Two wires, and they're on opposite sides. They're not on the same side because that would make it very different. I'll try to be very specific. The wires are anchored 60 meters apart. Anchoring means that's where it's kind of like attached to the ground. Okay. One wire has an angle of elevation of 62. The other one has an angle of elevation of 75. Sketch this scenario. Okay, so let's try that. I'm going to use my ruler here. So in this case, I would just say there's a ground there. And there's an antenna, a radio antenna. Is it perfectly halfway in between them? Look at the angles. One is at 62, one is at 75. We don't have an isosceles triangle here, so I would bring it closer to one rather than the other, right? So this is my antenna. Bring letters in that will help you out. So I will call this wire 1, W1, and I will call this W2. And at the top here, I'm going to call this A for antenna. And I do think it matters, like 62 degrees is smaller than 75, right? So I will make the one that's further away, I'll make that be the 62 degree wire. They don't specify. They don't say the left one is 62 and the one to the right is 75. So that it doesn't affect it really. But here are my supporting wires, and here are the angles, and I have one more that I need. I need the fact that they're 60 meters apart. So 60 meters, the problem I have with that is a lot of students think, oh, it's just 60 from the wire to the antenna, right? It's not. It's telling us that the wires are anchored 60 meters apart. So it is from here all the way to there. Okay, so it spans the whole base of our triangle here. What do you think, what angle is formed between the antenna and the ground? 90. I think it's safe to assume it's 90, right? If you don't, you probably get fired, or they make you redo the job, right? So this is the scenario here. What am I asking you for? Determine the length of each wire. Okay, so let's do that. Let's solve here. I will call this X, and I will call this other one Y. So those are the two wires that I'm interested in. How would I solve this? That's the question here. How many angles do you have? You've got two and one side that connects them. So how should I go about this? 62 doesn't have a side across from it. 75 doesn't have a side across from it. But this angle up here would have the side across from it. Can I find angle A, like this whole thing up here? Yes. What you need to forget about for a little bit is this one here. This is the one that throws students off, right? So don't worry about that one. We'll just figure out angle A. Angle A is 180 minus 62 minus 75. Angle A is 43 degrees. That is important to us, right? So if you want to go up here, and I'm going to use a red pen, but this whole thing is 43 degrees. So word problems bring all the things you've learned together. Okay. So now I have a pair, correct? Let's use sine of 43 over 60. Before I continue, I want you to make sure you understand this. 43 goes from here all the way to there, right? It spans the entire bottom side. And I'm saying this because sometimes the angle is 43 and the question only gives you this piece here, and students go 43 and this side. But if it's only to here, you cannot use 43 because it belongs to the big triangle, not just to the right triangle. So there we go. This would be, which one do you want to find first? Let's find side X first. That means I would have to go sine of 62 degrees over side X. And now it's just cross multiplying and dividing, right? If you do that, you get 84.98. Let's do the same thing again for a wire Y. That's my second wire. Sine of 43 over 60. And now I'm going to use sine of 75 allows me to solve for side Y. Okay, opposites. That's the way, that's the theme here. And this gives you 77.68. put this down a bit. So we've answered B. C. What is C asking? The height, yes. The height of our triangle. So, do you remember how to do that? You can pick a slant, right? And then sine of the angle that's touching it. So which slant should we pick? That's up to you. You've got a lot of information here. So I'm going to highlight the Y. I'm going to highlight that orange. Just so when I figure out the height that you know what I'm talking about. Height is slant times sine of angle. Yeah. These numbers?
Yeah.
You gotta be kidding me. Sine of 75. Did you catch that? Yeah, his own, you caught my mistake. Apparently I mixed up X and Y. Sine of 62. It's just this part here, the final answer. So this is 7768. Can you change that? Good thing I have students that pay attention. 7768, and this one is 8498. This would be a great question actually on a test. It would just take up so much room. How can you tell that my answers were wrong without even calculating anything? If I claim that the 75-degree angle, that should be the longest side across from it, right? But yet I was having the 77 as the answer. So it could not have been. So I did this on purpose to teach you how not to do it. Thank you. Let's do this again. The height is slant, which I'm going to use this slant here, which is 8498 times sine of A, which is this guy, this angle right there. Oh, is it home time already? It's lunchtime. 84, if you do this, you get 7503. Okay, homework. Pages. I'm going to say 39 to 41. They're not always easy, but you got to practice them, okay?